Take it away, sir.
Thank you. So, hi all. In this presentation, I'm going to go over how the infrastructure can be automated using the same Nephio principles which we have been hearing about since morning. And in this session, I'm going to explain the controllers that will sit in the Nephio management node. And by now, we all know what Nephio management cluster is. And the controllers, along with the KPT and Porch, basically they will reconcile to the infrastructure related KPT packages. And the southbound for orchestrating the infra or for creating the infra, the southbound controllers that we are going to use are the cloud provider controllers. So the example could be KCC for Google platform, or ACK controllers, AWS controllers for Kubernetes. So these controllers are basically CRDs, and these CRDs can pretty much create all of the infrastructure at the cloud provider. So the components that basically comprise this presentation and demo afterwards are the very basic is the KPT package. So we have created a KPT package which is comprising of KRM objects, and those KRM objects are the ACK objects, ACK resources, which basically create or define an EKS cluster. So with that KPT package, following the similar principle and similar automation principles as described in the previous presentation. So there is going to be a catalog repo where we can put this base KPT package. And then we specify a high-level intent for the infrastructure automation. The intent at the minimum will contain a pointer to the source repo where the KPT package will be present, and some more information like the region where you want to create the Kubernetes cluster, for example. And yeah, so that intent will be reconciled by this by the controller, which is the package deployment controller. It is the same controller that Wim demonstrated in the previous presentation, but it is a slightly older version of that. And then, so that controller basically, once it reconciles the infra intent, that will result in the creation of the EKS cluster. But that is not enough for making that cluster ready for the workload automation. So there is another POC controller that we propose in this presentation, and that is called as the Bootstrap controller. So Bootstrap controller's responsibility is to basically prepare the target Kubernetes cluster, and the bare minimum configuration that we want to have is to deploy config sync in the cluster and point the config sync to the cluster's corresponding Git repo. So that is the summary, the introduction, and so this slide basically explains the kind of operators that we have for this demo. So two operators, as I talked about, is two Nephio related operators, Nephio controllers. So one is the package deployment controller, and another one is the Bootstrap controller, which is at the POC level. So yeah, so the package deployment controller is, the custom resource of that controller is what going to be the intent, the infrastructure intent. And then in the southbound, the controllers which actually will create the infrastructure are going to be the cloud provider controllers. And in this example, we are going to create an EKS cluster. And for that, we have deployed the app controllers on our Nephio management cluster. But this controller is not dependent on ACK or AWS. we could use KCC, or we can even use crossplane, for example, which gives even another layer of abstraction over the cloud provider controllers. And KPT and Porch are the core of this demo. KPT, I mean, the package is being packaged as the KPT packaging bundle, and Porch is what the package deployment controller basically will use to clone the package from the catalog repo, hydrate it, and then push it to another repo, which we call as infra repo in this demonstration. So this is how the Nephio management cluster looks like for this use case or this demonstration. So the components that we have in the management cluster is Porch, as I spoke about. There is WebGUI, but we are not using that for this demo. By controller, I mean the Nephio controllers here. And the app controllers are the cloud provider controllers here. So there are repos which have the Nephio related packages, and the catalog repo has the KPT package for infra, and also the KPT package for an application which we are going to orchestrate. So basically, the demo will demonstrate the infrastructure automation followed by workload automation. So what we will see is that user specifies two intents at a high level. One intent will result in creation of the infra, and the other intent will result in the creation of the workload. So the workload is the example application is the caching DNS application. So that base package of the caching DNS application is also present in the catalog repo. And the dotted boxes, so these are the clusters which basically does not exist to start with, which do not exist to start with, because the automation is going to create these clusters and prepare these clusters by installing config sync. For this demo, I will create one cluster, and but the clusters corresponding Git repo is already existing. But imagine this as, I mean, in case of the complete automation, the basically controller should go one step ahead. It should create the cluster, as well as it should also create a repo for that cluster for complete automation. Yeah, so this is the management cluster. So these are the intents at a high level. So as I explained, two intents. So first one is the infra intent, which specifies the source repo and the properties of the cluster. And here the properties could be, I mean, the zone and region that you want to specify. And in case of AWS, whether you want to create your cluster in the wavelength zone, for example. And then that, as I said, that will be reconciled. That intent, which is a custom resource, will be reconciled by the Nephio controllers. Followed by that, the workload intent. Workload intent also specifies, so part of the workload intent talks about the placement, which specifies the placement intent, or which specifies the properties of the cluster where this workload should be deployed. So the very basic would be, it can just, the intent can just say the region where the workload has to be deployed. Or the intent could also talk in terms of some properties of the target clusters. It could say that I want to deploy my workload in a wavelength zone. So then the Nephio deployment package deployment controller will basically go and figure out the cluster which matches your intent, which matches the request in the intent, and will basically hydrate and push the package to that corresponding repo. So how the package deployment controller does that is that when we create infra, a custom resource, which is called the cluster custom resource, is created per cluster. And that CR contains the properties of the cluster. And the package deployment controller, basically it looks at the workload intent and reads the placement, placement intent related info from that. And it tries to match that info with the cluster objects that it has in the management cluster. And once it finds the match, it will basically resolve the placement intent and find the and basically push the hydrated package to the target repo. Another thing, so just going back to the same slide, is that so I have config sync in the management cluster here, but it could be a different kind of setup as well, where we have clusters dedicated for infra. And in that case, there will be a cluster which will have the config sync and which will have the cloud provider operators. And that is where the intent for the infrastructure automation will basically actuate. So any questions so far?
Yeah, there's a question from Lukash in the chat.
Well, I'm not sure if this is a question, so maybe we can deal with that after the presentation.
Okay, thank you.
Okay.
Okay. So yeah, so now I will describe what the demo is. So to start with, the config sync in the Nephio management cluster, it is basically configured to point to the infra repo, where the hydrated infra packages are put by the package deployment controller. And then we have the controllers that I mentioned in the management cluster. And then we create the package deployment CR, which is the intent. And that I will show that that CR file. So that it basically contains the source repo where the base EKS KPT package is present. And the controller reconciles it. So there is not much of hydration in this case. But yeah, it does some basic hydration and puts it to the infra repo. And then the config sync, which is configured or which is pointing to the infra repo, will basically reconcile it, which will result in the creation of the EKS cluster. And then the bootstrap cluster with bootstrap controller, which is basically a control loop looking over the cluster objects, will figure out that this new cluster object that has come into existence, by default, to start with, the cluster object has as a label which says that it is in not ready state. Then it will wait for that cluster object to come to a ready state, and once it is ready, it will do the basic bootstrap of the cluster by deploying config sync and configuring config sync to point to that cluster's Git repo. So this is the flow of what I am explaining. So the first intent is the infra intent. Nephio controller, the step number 1 in the sequence is via porch, pulling the package from private repo, manipulating it, pushing it to infra deployment repo, config syncing it, and then AWS ag controllers, they do their job and they start creating the EKS cluster. And then in parallel, the cluster bootstrap controller is basically watching this cluster's state. So it is basically watching one of the resources that is created by the ag controller, and that eventually comes to a ready or failed state based on the result of the cluster provisioning. And once it comes to ready state, it will install config sync, and that's when this this workload is this cluster is ready to basically have workloads. And then in parallel, somebody could, the user could specify the workload intent as well. And in the workload intent, user specifies the same cluster property, which basically belongs to the cluster that we created. And the package deployment controller will reconcile it. But it will see that the cluster object that is corresponding to this this cluster, which is selected for deployment, is still in not ready state. So it will keep waiting. Keep repeating this until that comes to that cluster object. Cluster object's label comes to a ready state. And once that happens, it will basically propose the package and basically push and propose the package to the corresponding Git repo. And then automatically the config sync in the target cluster will basically reconcile to that package, and that will result in the workload orchestration. This is the end-to-end flow of the demo. And so I have this demo recorded, and I will basically play that recording and talk through it. So can you see the
Yes, sir.
terminal? Okay, great. So on this screen, the left partition is where I will run the controller, infra deployment controller. And the right side is where I will apply the intents. So the controller has started running. So now first we will see the infra intent. So this is how the package deployment CR looks for infra. It has very basic information: package name and the repository, source repository where this package is present. So now we are going to apply this intent. So the controller in the backend would have reconciled it and pushed the curated package to the infra repo. So we will list the packages. So we see that the highlighted one, the first package in the list, is in the proposed state, and this is what the controller has pushed. And now we are going to approve it manually. So approving this, yeah. So this will basically trigger the creation of the EKS cluster. So now we will. So now then I went to the AWS console, and the EKS cluster has basically started to come up. So it takes some time for the cluster to come up. And then the process that I explained about the bootstrapping, so that will happen. And then, yeah, but in parallel, we can go and start specifying our workload intent. So this is the workload intent, same CR, same kind. And what it has is the name of the package. So we are going to deploy a caching DNS application, and it has the property. So these are the properties: region, US central one. So this is the same property which the cluster that we created has, and the package, the infra package that we had, so that had the cluster CR, cluster object, as part of the package itself, and that is applied already on this cluster, but it is in not ready state now. But the deployment controller will basically resolve this placement intent to our cluster because these properties match. So this is the cluster object I was talking about, which is already created because of the previous intent, that is, or previous CR that is reconciled. So it contains basic info. I mean, this is the scaling profile property of the cluster. And when the caching DNS application, when that is orchestrated, so that intent, like we saw, so that intent basically specifies a scaling profile. And the deployment controller, what it does is it looks at the scaling profile that is supported by the target cluster. And based on that, it hydrates the package. So based on that, it basically mutates the caching DNS package and sets the basically resource requirement, etc. for the caching DNS package. So that is the, I mean, for demonstration purpose, that shows a use case for hydrating, I mean, cloning, hydrating the packages. So now we will apply the workload intent. So this would have resulted in the cloning of the caching DNS package via Poach, and basically mutate the package as per the scaling profile that is supported by the target cluster, and then pushing it to the repo for the cluster which we created. So this is the new package, and it is in proposed state, and yeah, going to approve it. So then, I mean, we went back, and eventually the cluster did come up. It took like 12-15 minutes, and the bootstrap controller, which is at a POC at the, I mean, which was at the POC level when I recorded this demo. So it basically detected that the cluster has come up to ready state, created a kube config file for that, and deployed config sync in the target cluster. So config sync was deployed by directly calling the kpt commands, kpt live init, and that's how the config sync was deployed. And config sync was configured to point to the corresponding Git repo. So yeah, since both of the intents are applied, eventually the caching DNS application did show up on the target cluster. This is, yeah, so this basically shows that the application came up. So that is about the recording. And so what we saw was, I mean, from the user point of view, we specified two high-level intents, one for infra and one for workload. And the whole process of provisioning Kubernetes cluster to deployment of workload was taken care of by the Nephio controllers plus the cloud provider controllers. So this is, yeah, I mean, just similar to what Wim showed in the previous demo, another use case. So yeah, that's That's what I had for this presentation. Now we can have questions.
I would just like to thank you, John, for answering the question in the chat.
Okay. Okay. Thank you.
Okay, thank you. Stop.